Next, we want to look at reducing fractions to lowest terms, and in order to do that, we need a definition for what are called prime numbers. A prime number is a positive integer, that is a positive number, greater than 1, whose only factors are itself and 1. So a whole number greater than 1, whose only factors are itself and 1. The prime numbers are the set of numbers 2, 3, 5, 7, 11, 13, so on and so forth. All the numbers that have divisors of just themselves and 1 and no others. Now, when we do multiplication, we say 3 times 5 is 15. If we move in that direction, we're doing multiplication. These two numbers, 3 and 5, are factors, and that number 15 is called the product. If we take 15 and rewrite it as 3 times 5, then we're doing what's called factoring. Now, one of the things that we want to do to begin here is to take numbers and factor them into the product of prime numbers. Here's our first example. It says factor into the product of primes, and what we have is 215. So I look at my number 215 and I see that 5 divides it because it ends in a 5. So I'll divide it by 5. 5 divides into 215 43 times. So that's 5 times 43. I look at the number 43. It's a prime number. It has no divisors other than itself and 1, so it's in prime factored form. So I factor this number 215 into the product of primes. This is the way it factors. If this had been a 42, let's say, then I would have continued to factor until I couldn't factor any longer. Now, the next problem that we want to do is reducing a fraction to lowest terms, and it involves factoring. So here I have 42 over 66. The instructions are reduced to lowest terms. So I'm going to take 42 and write it as the product of prime numbers. 42 is 6 times 7, and 6 is 2 times 3. So it's 2 times 3 times 7. 66 is 6 times 11, so it's 2 times 3 times 11. Now I've factored the numerator and denominator into the product of prime numbers. What I want to do next is divide the numerator and denominator by any factors they have in common. So when I divide, for instance, the numerator by 2, what I'll be left with is 3 times 7. If I divide the numerator by 3, I'll be left with 2 times 7. To show that division, what I'm going to do is just draw lines through the factors that the numerator and denominator have in common. So when I divide numerator and denominator by 2, that's what it's going to look like. Then I'll divide by 3, I divide out those factors. What's left in the numerator is 7, in the denominator 11, so 7/11 is this fraction right here reduced to lowest terms. So that's factoring, that's what's called reducing to lowest terms, and I accomplish it by factoring the numerator, factoring the denominator, and then dividing out any factors they have in common. Here's our next example. For problem 3, we have 14 over 98. Now 14, if I factor that into the product of primes, it will be 2 times 7. 98 is 2 times 49, and 49 is 7 times 7. So 2 times 7 times 7. So I divide out the 2's that are common to the numerator and denominator, then I divide out the 7 that's common to the numerator and denominator. When I divide this numerator by 2 and by 7, what's left is 1. 2 divides into 2 once, 7 divides into 7 once, 1 times 1 is 1. So that's the new numerator is 1. The denominator is 7. So a lot of times students just getting started with this will write this as 0 over 7, something like that. It's not. When I divide out all the factors in the numerator, what's left is the fraction 1. Let's go on now and look at some fractions that involve variables. Have 42x squared over 30x. I want to reduce that to lowest terms. So what I'm going to do is factor the numerator into, let's see, it's 6 times 7, so 2 times 3 times 7. X squared is x times x if I write it in factored form. The denominator is 30, that's 6 times 5, so 2 times 3 times 5 times x. Now I'll divide out any factors they have in common. So I divide out the 2's, divide out the 3's, there's no 7's or 5's in common, and I'll divide out one of the x's. When I do that, in the numerator I have left 7x, and in the denominator I have left 5. So that fraction, 42x squared over 30x, in reduced form is 7x over 5. Notice it's in reduced form because it has no factors common to the numerator and denominator other than the number 1. Let's try another one of these. 66x squared y over 84xy squared. 66 is 6 times 11, so 2 times 3 times 11. X squared is x times x. and then I have that factor y. So there's all the factors of the numerator lined up. Let's see, 84 is going to be 2 times 42. 42 is 6 times 7, so I'll have 2 times 6, which is 2 times 3, times 7. So there's 84 times x times y times y, because y squared has 2 factors of y. Now let's divide out common factors. The 2's divide out, the 3's divide out, that x will divide out with that x, there's no more x's in the denominator, that y will divide out with that y. In the numerator I have left 11 times x, and in the denominator I have 2 times 7, which is 14, times y. So 11x over 14y. Now again, I want to remind you that if you're taking the basic math course, you won't see these fractions that involve variables. They're mostly for the pre-algebra people taking the class out of the pre-algebra book, but still for basic math students, it's the same idea in reducing to lowest terms, and it's a good idea to look at these examples anyways on the video lessons.